Hi everyone, welcome back to my channel where we talk about data visualizations in Python. So here at my channel, I've been asked numerous times to make a video about my thought process when I'm designing my data visuals. So today we're going to do exactly that. We're going to turn this plot into this one. I'll walk you through all the different styling decisions I made, and you'll actually get to see all of the Matplotlib and seaborn code. Along the way, we'll update our figure's title and its labels, its line widths and colors, its legends, and we'll also annotate our figure. So let's get started. By the way, all of the code I'm about to show you is available on my GitHub page.
So to get started, I'm going to go ahead and pull in a couple of libraries into my Jupyter notebook. I'm grabbing pandas as well as NumPy, and I'm also using this OS library, which will help me interact with the files on my computer. I've also got pyplot coming in from Matplotlib, seaborn, as well as this FuncFormatter, which we'll get back to in a bit. All right, so today we're going to be building a visual based on baby names. So this visual I first created for a blog post of mine called Measuring Statistical Dispersion with the Gini Coefficient. So if you want to see that blog, I'll go ahead and put it in the description bar below, but we're just going to be pulling one visual from that blog and recreating it here. So these data come from the US Social Security Administration, and these all contain baby names, years, states, and the count of the babies that were given that particular name, and also the baby's gender. So I'm going to be doing a bit of exploration here. I'm basically going to be looking for popular names and popular names by gender and the unique names per gender in these data. All right. So I'm going to go ahead and pull in those files. Right now, those files just live on my computer in a folder called Names by State. So I'm just going to be cycling over all the different files I have that are TXT files. I'll be pulling in each file individually through pandas read CSV, and then I'm just appending all of those as individual data frames into a list. Once I've got those all built out, I can go ahead and concatenate my list, and this gives me one main data frame that I'm calling names data. I've also got the columns of that data frame coming in here from this list. So we have state, gender, year, name, and how many babies were given that name. All right. Then I'm actually going to filter my data down. I'm only going to be looking at data that comes from 1950 and onward. Some of these names are from, quite a long time ago, the 20s, the 10s, etc. So we're really just looking more for more recent trends since 1950. All right, here's a peek at that data frame, just in case you want to see it. So we have, like I said, the state, the gender, the year, the name, and then how many babies were given that name per year, per state, per gender. Okay. So it turns out that in general, there is a higher proportion of male babies in these data. So here I'm doing a group by, grouping my data up by gender, taking those babies, summing them, and then dividing by the total number of babies. So just normalizing those counts. And it turns out that we have 47% females and 53% males. So it just turns out that there's more babies, male babies, that were registered through the Social Security Administration. All right, so I'm also going to be tallying up a couple of quantities here. I'll have the total babies overall, and I'm just summing over the babies column. I'll have the female percentage, which is that 47 that I just told you about, 0.47, and I also have the male percentage. So I'm just going to save these as variables, and then I'm going to eventually use them on my plots. All right. So the thing that I found really interesting about this data set, this was after exploring these data for a while, the thing that I found very interesting is that if you look at the top names that were given by gender over this time period, it turns out that those names were given to male babies. So let me tell you what I'm doing here. I'm taking that data frame from pandas, grouping by name and gender. I'm grabbing the babies column and summing that, resetting the index, then sorting the values by the most popular names per gender. All right, so we've aggregated over state and year, but we do still have gender being one of the components here. So let's take a look at that most popular names. All right, so at the top of the list, we have Michael, David, James, John, Robert, etc. So I found this really interesting that it turns out that out of these top 20 names, there are 18 of these given to male babies, and only 2 of them are given to female babies. There's Mary and Jennifer, I believe. Yes, Jennifer. Right. So I found this really interesting that, we have a roughly even split between female and male babies, but we just have a lot more male names in that most popular top 20. So I wanted to explore this a little bit further. How exactly is it that we have, we have a little bit more, that we do have a few more male babies, but maybe it's that the babies are kind of getting spread out among the female names, and we don't have super popular names bubbling to the top. So I was interested in that phenomenon. All right, so how are we going to do this? Well, what I want to do now to further explore this point and test out this hypothesis, I'm actually going to plot out the unique names by gender by year. So this is how many names are included in these data sets, per gender per year. Okay, so I'm taking my data frame, grouping it by year and gender, taking that name column and just counting the number of unique, so n unique here. I'm also unstacking this so that I can have things ready to go for the plot, but let me go ahead and show you what this looks like. Once we get that calculated out, here's the top of this data frame. We'll have years, and then we'll have the female, how many female names were there, and then how many male names were there. Okay, so at this point, I'm going to just go ahead and do a simple plot for this. I'll do a simple plot here, and then we're going to stylize it quite a bit. What I'm going to use pandas to actually plot these data out. So let's do this unique names per gender data frame, and I'm just going to do dot plot. So what we have here, across the x-axis, we have the various years, and on the y-axis, we have the number of unique names in the data set per year per gender, right? So what we're finding here is exactly what my theory was, is that we have fewer females in this data set. Remember, it was only 47% female, but we have far more names for the female babies. So that blue line, which is our female line, is always on top of the male line. We have more names for females for every single year. So this was an interesting phenomenon, I thought, because I went ahead in this blog and explored a concept called statistical dispersion, and I did that through the Gini coefficient. We're not going to do that in this video, but what I want to emphasize with this particular plot, we're going to style it a lot more, is this point that there are fewer female babies in this data set, but there are more unique names for those female babies every single year. So the female babies are kind of getting spread out among these many names, while the male babies are given these like really ultra popular names. Okay, so that's the goal of my plot, and I think that's kind of the critical piece of designing any figure, is just to think about what is the main thing I'm trying to convey with this figure. I need to know what that central idea is, and then I need to make that idea really easy to understand when I make my plot. Okay, so let's go ahead and style this figure and try to get across that message very quickly, that there are just more names for female babies, even though there are fewer female babies in the data set. Okay, so there's a lot of styling I want to do here, but the very first thing I'm going to do is actually change the dimensions of this figure. What I would like to have happen here is to have a little bit wider of a figure. So what I can do within this plotting function, by the way, we're using pandas to plot here, so the syntax might be a little different if you're using other libraries. But here, I'm just going to go ahead and write fig size directly in this plot function, and I'm going to change this to 10.5. That will make my figure a little bit larger overall, and it'll also make it a little bit wider instead of tall. And I like this because I want to kind of spread out the year so that we can kind of see the overall. And also it looked nice on my blog. These dimensions just happen to work well. Of course, you can play around with that as you're making your own figures. All right. The next thing I'm going to do here is go ahead and style those lines a little bit. So first things first, Oftentimes you might want to make thicker lines. If this is the only thing going on my figure, I might want to make those lines stand out a little bit more. So one way to do that is to change the line width, and I'm going to upgrade that to 3. The default is 1. I'm just going to make those thicker at 3. All right, the next thing I'm going to do is change the color of these lines. So the default here is going to be blue and then orange, and then we'll cycle through other colors as well if we have more lines. But in this case, that top line is the female line, and that's the one that I'm really focusing on for this plot. So I'm going to give it a really strong color. The male line is more for reference, right? So I want people to be able to compare these two lines, but I want them to be drawn to the line for the females, because that's kind of what we're focusing in on for this particular point. So to do that, let's go ahead, I'm going to jump down to the next line here. Let's go ahead and update the color. So if I have two lines like this, one thing I can do is just pass in a list. So what will be the color of my first line, and then what will be the color of my second. So for my first line, I'm going to use this color called Fire Brick. It's going to be a nice red color, but of course you can choose whatever color you'd like. For the male babies, I'm just going to change this line to gray, because remember, it's just a reference line. So let's go ahead and try that. Now we have a nice bright red color there for the females and a darker gray for the males. One thing that you might also want to pay attention to here, how is this graph going to get conveyed? If I'm going to be printing this one out in a black and white printer, I might decide to choose my colors a little differently so that will show up. I might even decide to change the line styles so that it will, be converted when I do black and white printer. So think about those kind of things. Also think about if any members of your audience might have color blindness. You might decide to go with different colors. Red is oftentimes one of the harder colors to see. Okay. All right, for this case, I'm going to go ahead and stick with my Fire Brick Red there. And let's go ahead now and change some of these labels. The next thing I want to do is change the labels. So along that x-axis, I have a year label. I might decide to go ahead and remove that because my audience can probably figure out that that's the year on their own, especially when I'm going to add a nice title and those kinds of things, and in the context of the blog, they'll probably be able to figure out that that's the year. So I might decide to completely remove my X label. If that's the case, I can use pyplot to say X label and then just pass in the empty string, which will remove that. But the y-axis is a lot less understandable, right? If I just looked at this plot, I would have no idea what the y-axis is conveying. So let's go ahead and label that one. So I'm going to put in here unique names in data set, something like that, something that's a little bit more descriptive. Okay, so this is printed out, unique names in data set along my y-axis. At this point, I might decide to change my styling of this though. Because that text is kind of tilted on one side, it would be difficult for my audience to be able to read that really quickly when they're looking at my figure. You basically have to tilt your head to the side before you can read that. So one thing you might want to do is rotate that text. So let's go ahead and try that. If I want to rotate a text in Matplotlib, that's going to be called rotation, and we'll set that equal to 0. Okay, great. Now we have that horizontal, which is going to be easier for my audience to read, but as you can tell, it's running into my axis. So we're going to need to move that label a little bit. And one other thing I'm going to do, because unique names in data set is kind of long, I'm going to actually put a carriage return, a new line character in here. So let's put a new line character right there. This will break it up so that I have unique names and then in data set on the next line. So I find that to be really helpful if I have longer names for some of these labels. So we definitely need to move that Y label a bit because it's running into our axis. So one thing we can do here is specify the position for that label. There we go, position. So this is going to be what will be the X position and then what will be the Y position. So you can think about your figure as being 0 to 1 and 0 to 1. On both axes. So I'm going to actually move this outside of the X axis. So I'm going to use -0.1, which will move it outside of my figure, and then let's say 0.9 to move that label up a bit. All right, great. So there we go. So we have up in this upper corner, which is going to be a nice spot where people will see that label really quickly. I've moved it out a bit, but we need to keep working on this a little bit more, obviously. Let's go ahead and do some font styling. Let's do font size. Let's increase this to maybe 16. This is just going to help our readability. We might also decide to change the alignment of this text. So right now it's center justified, but let's actually change the horizontal alignment, HA, to left justified. All right, so that's got it here. We are getting closer, but we still have the issue of that text running into our axes. So the next thing we need to do is add a label pad. Label padding will just start moving this label outside of the figure area, so it's going to pad it away from the axes. So let's bump that up to maybe say 125. All right, that's looking better. So we've moved this Y label position up to the top corner, and we've also been able to move it outside of the figure area. The last thing I think I want to do here is change the color of this. With that darker black color, it may distract someone from the actual figure itself. So let's actually change this to gray, just so that it's a little bit more in the background. That's starting to look really nice. The Y label looks really good, but one thing that's definitely distracting me at this point is this box that's around my figure. I really don't like having that box around my figures because I think it distracts people a lot, and what would be probably nicer is to have a little bit more open space here so that we can focus in on those lines. So I'm actually going to use seaborn to do this next step. I'm going to say seaborn despine, and you'll see what this does in just a bit. It's basically just going to remove the upper spine as well as the right spine. Great. So that I think looks a lot nicer, and now we are just focusing right in on those lines instead of looking at that box. So the next thing I want to do is, because I only have 2 lines here, I just have 1 line for the females and 1 line for the males, it can be a little bit more taxing for my audience to need to use the legend. So imagine that you're trying to look at this figure for the first time. The red line is the female babies, but to know that, I would have to find the line, go look at the legend, figure out that it's a female, go look back at the line, etc. So legends are great if you have lots and lots of lines or lots of points. You know, it's a great concise way to store information. But if you just have 2 lines like this, you might consider labeling those lines directly so that someone doesn't have to do that mental adjustment of looking at the legend. So to do that, I'm going to add a little bit of text over here on the right-hand side that just says females. I'm going to label that line directly so that I don't even need to use the legend anymore. All right, let's try it. So to add text in Matplotlib, you can use plt.text. And here I'm just going to kind of hard code where I want this text. You could, of course, use variables here to be a little bit more sophisticated. But for me, I'm just going to figure out what X and Y locations I want to put my text. So I'm going to write females right up here. And that looks like my data ends in about 2018. I collected these data a few years ago. So this is 2018, and it looks like maybe about 5,500 for the Y position. Let's try that. All right, so 2018 is my X position, and 5,500 is my Y position. And then I just type in the string that I want to appear there. So females. All right, great. So I have the word females directly written by that line. So what I also want to do, if I'm going to take this approach, we're actually going to do similar things for the male line as well. But one nice thing that you should consider to do if you're going to do this is color this text the same color as the line. That makes it very clear in the audience's mind that this text goes with this line. So color is a nice way to kind of pair things up. So let's go ahead and switch the color, and I'm also going to do a bit more font styling as well. So let's go to Firebrick for the color. Let's increase the font size to maybe say 16 or so. And we can also make this bold, so that's font weight, bold, and let's see what happens there. All right, awesome. Okay, so we have females written here, and it is a little bit above the line because I'm also going to add in a little bit more text in just a bit. But now you can see that I can directly label that line, and the audience doesn't even need the legend anymore. We can also label the male line as well. So let's just copy everything here. Let's copy this whole line of text. And we'll add in a text for the male line as well. So this will be males. And let's put that one a little bit lower. That looks like about 4,200 or so. We can always adjust that later. The color is going to be gray to match the line. And let's go ahead and keep it font size 16 and font weight bold. We might decide to unbold the male line since it's not the one someone's supposed to pay attention to, but you can decide whatever makes sense for you here. Okay. All right, so because I've labeled these lines directly, what that means for me is that I do not need the legend anymore. So to completely remove the legend, we can use plt.legend, and we'll just pass in an empty list. This will tell Matplotlib here to completely remove that legend part of our figure. Okay. Unfortunately, and this is pretty subtle, it has removed that part of the figure, but check out this little tiny box that's been left over here. Typically when you do remove these legends, you have to do one more thing to get rid of that box, and it's called frame on, and you will set that to be false. There we go, now it's gone. To completely remove the frame around the legend, you will need to do frame on equal to false. That'll remove that little tiny gray box. Okay, and this is awesome. Now someone can just easily look at the figure, easily know that's the female line, a lot quicker than needing to do the mental math of going to the legend. Okay, so we've done a lot of good updates already, right? We've gotten rid of some of that outer box, we've updated some of the fonts, we removed the legend and labeled the lines directly. But one thing we definitely haven't done is given this figure a title. So we want the title to represent not just something like names over time or something like that. If we can, we should try to put our main point of the figure in that title. So this is one approach. If you do have a main conclusion that you want to address to the audience, why not just put that conclusion directly in the title or maybe in the title of your slides? So in this case, remember that our main point here is that there are fewer female babies in this data set, but there are more names for them, okay? So let's add that in as our title. To add a title to this figure, I can use pyplot and use title. Then I'm just passing in a string here. Let's write in something like fewer females in the data set, but far more names for them. Something like that. Something that's like exactly the conclusion that we want our audience to draw from this figure. Awesome. So there's my title, but I have a couple issues with this title. One, it's too small. We definitely need to increase the font size. Let's do that right now. So let's bump it up to, let's say, maybe 18. All right, great. So that's a lot bigger, which is nice. And you may decide to, instead of having that be in the center of the figure, move it over to the left. You can do that with loc equals left. And then the final thing I'm going to do is something that, I personally like, but you don't have to do this if you don't want to. See how the title is like almost running into the figure? Like it's really close here. Sometimes I like to add yet another new line below the titles just to move that title up a little bit. So here let's do \n, which will make yet a new line underneath the title, which is the way, it's kind of like a little hack of mine to just move that title up a little bit away from the figure. I just think that looks a little bit nicer. Okay, great. All right, so we have a title, we've got some labeled lines. Let's also add in just a little bit more text here. So the next text I want to add in goes along with the main point, right? We have far more names for those female babies, but there are fewer female babies in this data set. So I could actually label my lines by saying exactly what percentage of babies were female, right? So this is just adding supportive evidence for my main conclusion that there are fewer females in the data set, but more names for them. Okay, so let's add in that text. Go ahead over here to this line. All right, that's going to be another plt.text. And I'm just going to put this text for the females directly below my label there that says females. Okay, so that's going to be still 2018 for the X position. Let's put this at about maybe 5,200. We'll see what that looks like. We can always, move it back up. This is just going to be what % of babies in this data set are females. So I'm actually going to use something called an F string to do this. So I'll write a little letter F outside, and what that's going to allow me to do is put variables into this text. Anytime I have two curly braces, Python will actually evaluate that as a variable. We'll evaluate the variable, convert it to a string, and then it will allow me to print that out. So in this case, what I want to print out here is that female %, which is the variable that I created up here. When I say, this female %, that's actually going to be what I print out now. Okay. So you can store variables, above and then print them out here. That's going to be 0.47, so let's multiply that by 100. Let's just see what this looks like so far. Great, so we have 47, which is our percentage of female babies, multiplied by that 100, but I have a ton of trailing decimals here. If you want to format any of these floats, for example, you can use a colon dot, let's say 0 for I don't want any decimal places, and then I'm saying that this is a floating point number. All right, so this converts my floating point number down to 0 decimal places. You can, of course, change this to 1 or 2 or however many decimal places you want. All right, so we're almost there. Once we have this 47, let's also put % of babies, something like that. So now I'm like directly telling my audience members 47% of babies are females. That's the point of adding this text, so that they have a reference point for how many babies are actually females. And let me just do a bit more styling for this font. Let's increase the font size to say 12. We might decide to make the color gray. And I'm even going to also make the font italicized. I think this is nice to add a couple different styles here. And this is totally your choice, but I'll change that to italic for now. Okay, looks pretty good. I actually might move it a little bit more to the right. It's kind of running into the line. Let's do that. Maybe I'll do 0.5, just check it, see if I like that. I do like that a little bit better. So I just shifted a little bit to the right. So 47% of babies are females. That gives my audience a really nice reference point, and I can just copy this. Let's also add something about the males, pretty much the same thing, except for we will switch this over to the male %. And let's move that down to, what does that look like, about, 4,000. That's about the area we want that. Oh, that's a little too low. See, so you can kind of just shift this as you'd like. All right, awesome, that looks good. So now I have 47% babies are female, 53% of babies are male, and that's directly written on my figure. Okay, so the final thing I'm going to do for my figure is actually update the tick labels. So right now they're a little bit small, and I might also decide to make them gray so that my data pop off the figure and that I'm not distracted by things like the tick labels. Okay, so since I want to adjust the formatting for both the X and Y axes, I'm going to go ahead and grab the current axes, which is plt.gca. So ax will now be a variable that represents the axes of my current figure. Then I can use ax to update the tick params. Now the nice thing of doing it this way is that you can say in here axis equals both. So any styling that we do within this method here is going to be applied to both the X and Y axes. All right, so let's go ahead and say that we want to change the colors. We're going to update that to gray. We're also going to change this to our label size will now be 14, so that's increasing the size of those labels. And let's also do this length equals 0. So this is actually just going to remove those tick marks, right? So the little dashes that come with all those ticks. All right, let's try that. Awesome. So now you can see what's happened. We've updated these to be a little bit larger, but gray, and we've also removed all those little dashes. These are personal styling choices at this point, but I think this looks nice. So the next thing I'm noticing here, the y-axis doesn't actually start at 0. This is something that we probably do want our y-axis to start at 0, unless it's a trend that we're trying to zoom in on. So in this case, I could easily start this as 0, That'll just help me figure out, kind of help me baseline how many names we have. So if you do want to change your axes limits for any of these, you can use this, let's go ahead and put it back up here. We're going to use plt.ylim. So I'm going to start this figure at 0, and then I don't really care what it goes up to. So if I want to use the default of whatever Matplotlib thinks is a good place to end, I can use none. So it doesn't change the topmost, but it only changes the bottommost. All right, let's take a look at this. So now we're starting at 0 and we're going up to 6,000. Great. All right, so the final thing that I might want to do here is, I'm starting at 0, but I might not actually want to see the 0 now. So if I want to remove that, I can use ax to go ahead and get my y ticks. And I'm just going to store all of these in a variable, let's call it g. Then I can go ahead and say plt.yticks, g going from 1 up to whatever, right? So I just want to remove this 0. It's kind of standing out and it's not super nice to look at. I just want to remove that, so I'm going to exclude it from the list of tick marks that I'm passing in here. Okay, that just removes the 0. Personal styling choices at this point. So now the final thing that I may want to do, and I don't have to, but at this point, just a kind of a personal choice. Right now I have on all of these y ticks, 1,000, 2,000, etc. I may decide to switch this over to something like 1K, 2K, 3K, etc. So I basically just want to show you how this would work if you do want to change the formatting of those strings on your tick labels. All right, so let's try this. So I'm going to do my current axes, ac, and I'll go ahead and just get the y-axis, okay? So once we have that, then we're going to do this set major formatter. Okay, so this is going to be the formatter for my major tick labels. So that's major being the ones that are actually currently displayed. Okay, set major formatter. Then we're going to use our FuncFormatter from the very beginning, and this was something that I had to import, which I did at the very beginning of this notebook. Okay. Within FuncFormatter, we're going to produce both the actual string that will appear on the label, as well as the position for where that label should appear. So I'm going to use a lambda function to do this. I'll have x and p, where x is the string that's actually going to get produced, and p is the position where that label should be. Okay, so the way that I'm going to structure x, so for every current tick that we have, we're going to convert it. So in this case, that's going to be, I'm going to pass this through this format. Then I need to go ahead and convert this to a string. It will be an integer, which is x divided by 1,000. So this is going to take all of those current values, say 5,000, divide that by 1,000, so I'll have 5, which will be an integer instead of a floating point. Then I'm converting that to a string, and then to that string, I'm just going to add the letter K, okay? I'm going to convert everything. Instead of saying 5,000, I'll say 5K. Then I'm creating this new format for all of the actual labels, but the position stays the same, which was P. All right, let's try it. Awesome, so now we have K instead of the 1,000. Just wanted to show you this FuncFormatter. This is how you could convert things like if you had millions, maybe you'd want to convert that to the word million or a $sign, etc. Okay, so lots of options for you here, and you can get this figure to look exactly the way you like it.
So thanks so much for watching, and I hope you got a lot of good tips out of that. Throughout this process, we saw how to label our lines directly instead of using a legend, how to annotate our figure with the key points, and also how to update several of the fonts, including those tick labels, through the formatter. If you liked this video, go ahead and give it a thumbs up. And this video was inspired by a viewer of my channel. So if you have any plots you'd like to see me make, go ahead and let me know about them in the comment section below. Thanks so much, and I'll see you next time.